Alright, Algebra 2. So this problem says Selena is standing on a rock cliff that is 52 feet high. She tosses a pebble upward over the edge and it lands on the top of a 12-foot high boulder. The quadratic equation that models the path of the pebble is here. And how long did it take for the pebble to hit the top of the boulder? Okay, so we kind of have to model this situation. So she's standing on a rock cliff. Alright. That's 52 feet above the air. Okay, there she is. She's up here. And she throws this rock, which is going to always, whenever you throw, you can imagine it's always going to go up a little bit before it starts going back down. And then it says it hits a rock, a top of a boulder, which is 12 feet high. So this is 12 feet. Okay, and that's where it lands. Alright, so there's a few different ways that we can do this. One thing is that we know that the height at this point here is 12 feet. So you can replace the height, p of t, with a 12. So we could say 12 equals negative 16t squared plus 12t plus 52. And in order to solve something for t, for time, using the quadratic formula, you'd have to subtract 12 from both sides, because remember, quadratic formula finds the zeros. So we could do that. So 0 equals negative 16t squared plus 12t plus 40. And then we can use the quadratic formula from there. Another option that we have is to graph it. So I'm going to pull up what it's going to look like on the graph. Alright, well, first of all, we know we're going to have to type in our y equals. We're going to have to type in the equation that the rock follows. So you're going to have y1 equals negative 16x squared plus 12x plus 52. And then the other thing we're going to have to do, we're going to have to put in our other y equals. We're going to have to put in 12, because we want to know when this reaches a height of 12. And we decided that our y's are 12, or our height, because it says this is your height, because t is time, and that's what we replaced with an x, as you can see here. Okay, so we have to set those two. Now, when you first graph this, and if you're in your like normal screen view, I'll show you what you'll see. Something along the lines of it'll be something like this here. Okay. Well, we can't see what we need to see, so you're gonna have to change your window. What I would do is, because I wanna make it a little bit narrower, and I want to be able to see a little bit higher. So I want to change my x min. I want to change my x max, because remember, min is a low, which would be the left, and then max is a high number, so that would be the right side here. And then I also want to change my y max. I want that to be higher. So I'm going to change my y max to something like 50, because I want to be able to see something higher. I'll change my x max to something lower, like 5, and my x min to something like negative 5, so that I'll only see from here to here. That's what that means. So I'll show you what that'll look like. That's going to give you a graph that looks something like this. So you'll notice, okay, there's our pebble falling. Now we don't have to think of anything that is on the negative side, because we know there's not negative time and any negative height or anything like that. So we can actually just eliminate all of that from your brain when you're looking at it. So we have, there's the rock, and then, oh, that's when it hits that 12 feet right there. X marks the spot. So we need to do second calc, because all the calculation things are there, and we'll do, this is an intersection. So we're going to find the intersection, and then when it says curve 1, you have to go along this line. You want to try to click right along that intersection point, and then curve 2, the other one. It doesn't matter which one you call curve 1 and curve 2, but you just have to bring the cursor to that point on both of those lines, and you hit guess, you bring it to right there, hit enter, and it'll tell you your answer of, you'll get your answer of x equals 2. Now it says y equals 12, but remember that the y was the height, and it's asking us for the time, so x equals 2, we can go back up to the top. There it is, 2 seconds. You'd also have gotten this if you used the quadratic formula.